So as I was saying, what I'm proposing to call the age of catastrophe is what many geologists nowadays are proposing to call the Anthropocene, because it is an obviously humanly caused geoplanetary event. And what I want to do is glance back at the geological history for a moment, because it tells an interesting story about CO2 that most people don't often hear. You get comments like Gore saying in An Inconvenient Truth that CO2 is the highest it's been in 600,000 years. But in fact, it's the highest it's been in 3 million years, actually. But if we look back at the Devonian for a moment, the Devonian is a period that extended from 415 to 360 million years ago. And it's the period where the first amphibians begin to crawl up out of the water, and the CO2 was very, very high, the highest that it's ever been in the entire history of terrestrial animal life. It may have been higher in earlier, older epochs, but at that time it was 2,200 parts per million. That's inconceivably high. But then what happens is that it gradually comes down. The Carboniferous is the age that comes after the Devonian, and which extends from roughly 360 to 300 million years ago. And in the Carboniferous Age, the CO2 begins at about 1,700 ppms, and the sea levels are at about 100 meters higher than they are today, and the global average mean temperature was, say, it was 4 degrees hotter than it is now. And what happens during that epoch is that the carbon dioxide gradually comes down. Bit by bit, it comes down until you get to the end of the Carboniferous period, approaching about 300 million years ago, and it's down all the way to about where it is today, a little bit lower, 375 parts per million. And so there was a cooling period going on there that continued on through the Permian, which is the next epoch, which is roughly 300 million to 250 million years ago. Then we come to the Great Permo-Triassic Extinction Event, which took place about 250 million years ago. There have been 5 such extinction events, and one of them we know, the one that killed off the dinosaurs, was caused by a bolide, a comet, that crashed into the Yucatan Peninsula and killed off all the dinosaurs as a result of a cooling event. But the other 4 events, as Peter Ward argues in his book, The Flooded Earth, seem to have been caused rather by global warming events and massive influxes of CO2. So the Permo-Triassic extinction event that took place 250 million years ago was the result of massive amounts of CO2 being pumped into the atmosphere through volcanic eruptions. And I don't know what caused them. I'm not sure if we do know exactly what caused them. But it pumped the CO2 all the way back up almost to where it had been in the early Carboniferous, to about 1,700 ppms, which set the stage for the hothouse Earth for the Mesozoic, the period of the dinosaurs that followed, Triassic, Jurassic, Cretaceous, that followed from about 225 million years ago all the way down to 65 million years ago, which is the hottest period on Earth. At its height during the Cretaceous, sea levels were actually 220 meters higher than they are today, so that was something like 600 feet. I don't think they can ever get that high again. I think the geology was different. And the global temperature, though, the global average temperature was about 18 degrees Celsius higher than it is today. It was very, very hot. And CO2 levels were at about 1,500 parts per million. But then after the next extinction event, where the comet comes in about 65 million years ago, it brought the CO2 levels down. It created a cooling event. It brought the CO2 levels down to about 1,000 ppms in the so-called Paleocene. And the Paleocene now is about 55 million years ago, 65 million years ago to 55 million years ago. And then the Eocene comes in 55 million years ago, and it lasts down to about 35 million years ago. And during that period, the CO2 slowly cycles down, down, down. 40 million years ago, it's at 540 parts per million. 30 million years ago, it's at 375 parts per million. And at about 35 million years ago then, as the carbon is coming down closer to 300 ppms, the West Antarctic ice sheet then forms. And for the first time we get, there had been ice at the poles in earlier times, in the Devonian, for example. But we get the formation of the Antarctic ice sheet 35 million years ago, just as the CO2 levels are going down around 300 parts per million. So it's getting cooler, and the Earth is trying to cool itself off, apparently, because by the time then we get to the Pliocene is 3 million years ago, and CO2 levels are at about 400 parts per million. The sea levels are at about 25 meters higher than they are today, and the global average mean temperature is about 3 degrees hotter than it is. But then we get, as things are cooling off, we get about 2.5 million years ago the shift into the Pleistocene, or the Quaternary as it's also known, which is, for the past 2.5 million years, the current ice age cycles, the current ice age oscillation between an ice age and an interglacial, ice age interglacial, that's been cycling now for about 2.5 million years. During that entire period, the CO2 never got above 280 parts per million. It's gone back and forth between about 280 and 180 ppms during this whole past 2.5 million years. It's never been up over 300 parts per million until the year 1900, when it went up to 295 and then started to go over, coincidentally perhaps, at just the time when the fossil fuels are working and the factories are pumping all the fossil fuels and the CO2 emissions for the first time happily and merrily and carelessly into the atmosphere. Then they start going up, and they've gone up by 100 parts per million since then. That's astonishingly, staggeringly fast. In just a century, sea levels have risen by 1 foot also in a century. And so that's not an accident. So there's a direct correlation here between CO2 and warming. So the global warming skeptics who say, no, there are these natural warming epochs, such as, for example, the warming age that occurred prior to the mini ice age that we were in from 1500 until just prior to this, 1500 to 1800 roughly, there was kind of a mini ice age that made Europe very, very cold. But prior to that, between 900 and 1400 AD, there had been a warming period, and it was so warm indeed that it enabled the Vikings to set up colonies on Greenland. It was a nice, warm, cozy place. But the CO2 levels, what gets left out of that, the CO2 levels never went over 280 parts per million during that period. So it doesn't take that into account. Now that the CO2 levels are going up, the temperature is going up. The global mean average temperature has risen by 0.8 of a degree, and the carbon is going up very fast. As I say, by 2050, most of our climate scientists are saying that we will be at 450 ppms approximately, approaching 500 ppms, if not at that point. At 500 ppms, that's a danger sign. That's a point that we don't want to go beyond. At 500 ppms, the oceans start to get very acidified, and the acidification will begin killing off the ocean algae. The ocean algae are a considerable source of pulling CO2 down out of the atmosphere. So that will be gone, in addition to all the deforestation that's going on. And the sea levels will rise probably by another foot by 2050. And then there are various figures proposed for how fast the sea levels will rise by 2100. The most conservative estimate comes to us from the IPCC. Their politically hands are tied, so they're always going to give conservative figures that don't scare people, and they say at the most 3 feet by 2100. That's still a big problem, but it's a nice, slow, cozy figure. But James Hansen, the climate scientist at NASA, says no. If you look at the rate that the glaciers melted during the last ice age 14,000 years ago, once it got going, it transpired at a rate of about 1 meter every 2 decades. So that's 5 meters in a century, and 5 meters is about 15 feet roughly. So by 2100, once this gets going, we're going to be looking at sea level rise 10 to 15 feet by 2100. That's catastrophic, and it's very bad news for our coastal cities. Many of them will be uninhabitable. Bangladesh, which is one of the low-lying areas, will be completely flooded and uninhabitable. It's packed with humans. There's like 150 million people there in a very small area. 10 million people will be displaced by just a sea level rise of less than a foot. That will displace 10 million people there. So we're going to look at a century here of massive population displacements and exoduses and various famines and droughts. Also, Holland is in big trouble. Once the sea levels get at 3 to 5 feet, Holland is in big trouble, and many of its cities will probably have to be evacuated. New Orleans, of course, will be underwater by 2100. There's no two ways about that. It will be underwater. So all the world's low-lying areas will be underwater by 2100, whether you look at it at the conservative figure of 3 feet or James Hansen's non-conservative figure at 10 to 15 feet. Those areas are going to be underwater. And then so it's a matter of the rest of this unfolding through the subsequent centuries, 3 to 4 to 5 centuries. By the time you get to the image of New York in Steven Spielberg and Stanley Kubrick's film AI, that image of New York will transpire in about 500 years from now, roughly, when all the ice melts in Greenland and Antarctica, and it will melt. 7 meters sea level rise when the Greenland ice sheet melts. When all the Antarctic ice melts, it'll go up even higher. The maximum it can go up is 80 meters, so we're looking at about a 240-foot sea level rise over the next few centuries. But by 2100, it's going to be a dire situation. So, and probably already by 2050, low-lying areas like Bangladesh are going to be in big trouble, and probably New Orleans also. And the other factor that doesn't often get taken into account here is that, as with Hurricane Katrina, as the seas rise, the problem is what doesn't get taken into account, especially when the dikes are rebuilt, as New Orleans were recently refortified and rebuilt to withstand a Category 3, is that it doesn't take into account storm surges that come in and raise the sea level by another 3 to 10 feet off of rising, warming waters. And it's those sudden catastrophic effects from storm surges, and we're seeing a doubling now of hurricanes. There have been double the number of Category 4 and 5 hurricanes since the 1990s, since which decade, by the way, 10 of the hottest years ever, 10 to 14 of the hottest years ever on record have transpired. The hottest years on record, by the way, for the record, are 2005 and 2010, and it looks like 2011 is right behind that, and 2012 is going to be right behind that. So we're looking at very, very hot phenomena. And so when we come to the age of catastrophe, which is the third epoch, this long detour to get to this third epoch, where we have something like Hurricane Katrina, where we have a Category 5 hurricane coming in off the ocean, and by the time it makes landfall, it's downgraded to a Category 3, but even so, it floods the city. We have a hurricane that might be a natural disaster, but we can't rule out the effects of global warming amplifying it. It probably would have been, let's say, a Category 2 or 3, but with global warming, it gets amplified. These hurricanes double in frequency and in strength as the result of global warming. And so there really is no such thing as natural disasters anymore. There was a guy interviewed, a climate scientist, I forget his name, interviewed on NPR a few weeks ago, and he said, well, now hold on, we don't want it to sound like everything that happens is part of global warming nowadays. But see, my point is precisely that everything that happens is now a function of global warming, because there's no way any longer to separate them. Now, the thing with earthquakes, tornadoes, hurricanes, and so forth, which apparently seem to be natural disasters, not man-made, the problem is that with earthquakes, some geologists are saying that earthquakes, too, may be tied in with global warming. They are on the rise, and they appear to be becoming more and more frequent. We've had 3 tsunamis in a decade. When I was growing up, I don't remember any tsunamis, but we've had 3 in a decade now. And the theory is that possibly, as the ice melts off the Greenland continent, as it melts, it relieves the plates of pressure, and that loosens them, and they start to kick around. And it makes more tectonic activity happen. And conversely, there's an opposing theory that says as the sea levels get heavier, as the ice melts, they put pressure on the tectonic plates, which also causes them to move around. So if there's anything to this theory of global warming being linked to the increase in earthquakes, earthquakes should be on the rise. We should see more and more of them, and so we can no longer rule them out as purely natural disasters. We're thinking in terms of the rear view effect nowadays. We're looking at today's problems through yesterday's epistemological lens. Natural disasters are non-existent because nowadays we're looking at a stage that has been so managed by the human presence that there's no way anymore to separate natural from industrial or man-made causes. The two have become enmeshed. Nature has become entwined with civilization to the point that there's no way anymore to tell the difference between them. Nature has now been engulfed by civilization. It's been swallowed up, and conversely, catastrophe has engulfed civilization and swallowed it up. So there is no longer any way of demarcating nature from civilization, of building great walls, like in the time of Shi Huangdi in the Qin days of 220 BC, when the Great Wall was built. The Great Wall was built, and the barbarian Xiongnu were on the other side, and we civilized ones were on this side. It's no longer the case anymore. There is no place where we can be safe from disaster now. It's everywhere because it is a global event, what Paul Virilio calls an integral event. It's an omega catastrophe. Global warming is the mother of all catastrophes. It's the omega accident, the greatest accident ever of all time that has been set in motion as the result of the collision of industrial civilization with the biosphere. Industrial civilization smashed right into it, and this is perfectly symbolized and foreshadowed by the Titanic hitting a 10,000-year-old piece of Greenland ice, which is what I talk about in the essay on the Titanic. And it's an omega catastrophe. It's unfolding in slow motion all around us, and it's not something I believe we can stop due to climate inertia. It'll take thousands of years for the CO2 that we've already put in there to cycle down. And we're going to put something like 3,000 more gigatons of CO2 into the atmosphere. It's going to keep going well up over 1,000 ppms. So we are indeed looking at an age of catastrophes in front of us.